Good evening, class. As we have discussed in our last class, triaxial test in shear strength of soil, we were left with a few topics in this chapter, starting with procedure to determine the shear parameter. Procedure to determine the shear parameter. The shear parameter which we have to determine is C and phi, which is known as which are cohesion and internal angle of friction. We know that triaxial test is performed in two stages. Stage 1, known as confining stage, cell pressure stage, or consolidation stage. In which the stress is applied from all the four sides, which is known as minor principal stress or confining stress. Okay, it will be applied by the help of it will be enclosed with the rubber membrane, and after that the water will apply the pressure from all the four sides, which will be inside the plastic membrane or the glass membrane of the triaxial test. Thereafter, in second stage, this stage starts after the stage 1, and this stage is also known as shear stage or deviator stage. Shear stage or deviator stage. This stage starts after the first stage. So the this stress will be applied with the help of this stress will be applied vertically, and will calculate the dial gauge reading or proving ring reading from this test. And the stress applied will be known as the major principal stress or deviatoric stress, and this major principal stress will be till the failure plane is determined. After this deviatoric stress, as this deviatoric stress determines the failure plane, therefore it will, in triaxial test, it will also be known as confined compressive strength. Confined compressive strength, in which deviatoric stress determines the failure plane, and deviatoric stress, we know that it is sigma 1 minus sigma 3 at failure, which is also known as stress equals to load per unit failure area, right? This is in this way shear parameters are determined by this form, and this shear parameter can also be determined by analytical method. This is the first method with the help of laboratory test laboratory test, that is triaxial test. Now within this triaxial test only, analytical method will help to determine the shear parameter, that is C and phi. Analytical method to determine C phi. Here, as the equation which we have discussed earlier, one of the most important equation will be used. Sigma 1 equals to sigma 3 times 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. This will be equation in different test of the triaxial test. Suppose if we have to determine the undrained shear parameters. If you have to get the undrained shear parameter, we'll use total stress. If you have to get the drain shear parameters, we'll use effective stress. So uh, in short in short, we'll do it as, for CD test, consolidated drain test, both the walls are open. Remember, in consolidated drain test, both the walls are open, pore water pressure, all the pore water pressure is expelled out. Therefore, the total stress will be equals to effective stress. Sigma 1 b is equals to uh, major principal stress will equals to this, equals to, although total stress is pore water pressure, but as all the pore water pressure is expelled out, it will not be taken. And on applying the these values will be applied on the above equation to get C5 values. Similarly, after consolidation test, we are having uh, undrained test and consolidated undrained test. In undrained test, unconsolidated undrained test, it is a quick test, both the walls are closed, therefore pore water pressure will take the load. Pore water pressure will take the load. We'll calculate the pore water pressure. We having unconsolidation situation, therefore we'll use total stress only. Total stress is effective stress plus pore water pressure, and the total stress, the minor total stress, is equals to minor effective stress plus pore water pressure. On applying this value in the above equation, we'll get C5 values. In consolidated undrained test shows, in consolidation part, in the stage 1, the walls are open, and as it is consolidated undrained, that shows the stage 2 is, the walls of stage 2 are closed. Therefore, walls of stage 2 are closed, pore water pressure will be considered, and as it is consolidated, effective stress will be considered. So effective stress will be total stress minus pore water pressure, right? On applying this value in the above equation, we'll get C5 value. This is these things has to be determined by the triaxial test. These are the analytical method to determine the C5 parameters. Now we should also be knowing about the failure area of cross section of soil at failure. So as on no, there are a lot of calculation derivation of this formula, but as due to the shortage of time, we'll directly write down the formula which is 1 plus minus epsilon v divided by 1 minus epsilon l. Epsilon v is volumetric strain and epsilon l is longitudinal strain. This is formula to calculate the failure area. If UU test is considered, in UU test the volume change is neglected. There is no volume change in UU test. There is no volume change, that is delta V equals to 0. That is volumetric change will equals to 0. Therefore, the failure area will obtain is A naught divided by 1 minus epsilon L. In this way, we calculate the failure area in triaxial test. Another important thing in this shear strength of soil is type of Mohr's failure envelope for different soil. Types of Mohr, these from these graph, the questions are asked in the exam. Types of Mohr failure envelope, right? These are quite important to understand. These failure envelope, or they are dependent upon the type of soil, loading condition, and drainage condition. Right, in this we'll discuss about the we'll discuss the failure plane of sand, we'll discuss the failure plane of saturated clay, mm, in undrained condition, saturated clay in drained condition, and partially saturated clay. Suppose we'll do it shortly. Like for sand, we know that in sand there is no cohesion, only internal angular friction is there. Therefore, the failure envelope which we'll obtain is, there is no cohesion, only the internal, only the yeah, internal angular friction is there. The cohesion, the Moore circle will obtain will be like this, and the Moore failure envelope will be as follows. Therefore, only 5 will be obtained. There C will be 0, and only 5 will be obtained. This is for the sand. This is Moore failure envelope, right? For saturated clay under, for saturated clay under undrained condition, under undrained condition, we know that in the saturated clay we having cohesion, and if it is asked for undrained condition, undrained means walls are closed, undrained means walls are closed, there is no drainage. It is a quick test. If it will be unconsolidated undrained test, we'll call it as a quick test. But in undrained test, the walls are closed, there is no expulsion of pore water, therefore we'll consider it as a clay, and the graph will obtain from the Moore failure envelope will be, uh, for saturated clay we having saturated clay having cohesion, we will get Moore circle like this. And if we'll draw the other Moore circle, will get the Moore circle of the same radius, we'll get all the Moore circle of same radius. Therefore the Moore failure envelope will be almost, will be parallel, which will be having cohesion and phi equals to 0. Why these Moore circle are of same radius? As you know, in undrained condition walls are closed, no volume will change, therefore no sliding or no friction, therefore all the radius, all the circle will be of same radius, right? As the, why these circles are of same radius? Because walls are closed, walls are closed. If the walls are closed, pore water pressure will not expelled out, no volume will change, right? No volume change, therefore no sliding, no friction, and the circle obtained will be of same dia, same radius. Saturated soil under drained condition, understand this, saturated clay soil or saturated clay under drained condition. Saturated clay, we know that in the saturated clay there is a cohesion, but understand this condition under drained condition. If the condition is under drained condition, if the condition is drained, then the pore water pressure is expelled out, pore water pressure is expelled out, right? The same situation we find, the same case we find for the sand, either it is for the short term or it is for the long term. So the Moore failure we will get is same as that of sand, in which we'll be having zero cohesion and only internal angular friction. Remember this for saturated clay under drained condition. We have studied this in the type of triaxial test, this thing in the type of triaxial test. Why is it so? We'll get same Moore failure envelope. This is also the Moore failure envelope. Sorry, Moore failure envelope. And this is also Moore failure envelope. Here only the phi will only get intertangle friction, cohesion will be 0. For partially saturated clay, we will get cohesion as well as phi. Fourth is for partially saturated clay. For partially saturated clay, the Mohr circle will not be of same radius, therefore we'll get slightly curved Mohr failure envelope, slightly curved Mohr failure envelope, which will give cohesion as well as phi, which will give cohesion as well as phi. Therefore, one more important term which has to be discussed in triaxial test is stress path. Stress path. Stress path. If we are having various Mohr circle under different loading condition, and if we join all the locus of the maximum shear stress of at different loading, we'll get a curve which is known as stress path. Joining. So what is the stress path? Stress path is, this is stress path. Joining locus of maximum shear stress at different loading condition. The curve obtained is stress path. We know this is sigma 3, major, minor, major, principal, sorry. These are sigma 1 only, major principal stresses. Now from here all the triaxial test things are completed. बस इसके बाद just एक चीज़, merits of triaxial test. Why triaxial test is used nowadays so much? Merits of triaxial test तो बहुत क्लियरली सबको पता है. पहली चीज़, हम ट्राइएक्सियल टेस्ट करते हैं जस्ट बिकॉज हमारे इसका फेलियर प्लेन डिटरमाइन नहीं होता है. फेलियर प्लेन इज़ नॉट डिटरमाइंड, विच इज़ द वीकेस्ट प्लेन. तो हमारा बहुत अच्छी बात है, विल गेट सम एक्यूरेट रिजल्ट. फेलियर प्लेन इज नॉट डिटरमाइंड, नॉट प्री डिटरमाइंड. प्री डिटरमाइंड, नॉट डिटरमाइंड तो फिर गलत ही हो जाएगा. And we having walls in the triaxial test apparatus, therefore drainage is controlled. Drainage is controlled, and one of the most important, suitable for all type of soil. And the last, stress distribution is uniform. Right, here we complete the triaxial test. After this, unconfined compressive strength test. Unconfined compressive strength test known as UCS test. It is a special type of triaxial test in which we do not apply there is no confining stress, that is minor principal stress is zero, that is minor principal stress is zero. Therefore, as we get the confined compressive strength value, which is determined by the deviatric stress at failure. Here we'll get the unconfined compressive stress value, which will also be determined by deviatric stress at failure, as deviatric stress at failure sigma 1 minus sigma 3 at failure, as and we know in this case sigma 3 is 0 because first stage is not in this UCS, because in UCS, which is P by open failure, what happens in the UCS test, the specimen which is applied load is not surrounded by any of the plastic or glass membrane, as it is done in the triaxial test. It is open from these sides. So this is suitable, this is not suitable. Also, one more thing, not suitable for sand and dry soil. Not suitable for sand and dry soil. And the Mohr circle we obtain in this unconfined compressive strength test is the unique Mohr circle, and the and if we'll apply this value, if we'll put this value in the equation, which is one of the most important equation, sigma 1 equals to sigma 3 times 45 plus 2c 45 plus 5 by 2, we'll get the values which are asked in the exam. No, the value, the equation, if we'll put these values in this equation, able to determine the shear parameters. Sigma 3 is 0, therefore what we get 2c tan 45 plus 5 by 2. This equation is used to determine the shear parameters of the soil. If the soil is clay under undrained condition, this is unconfined compressive strength test. If the soil is undrained, in undrained the soil is undrained, what we got when the soil is undrained, we get phi equals to 0 when the soil is undrained. Therefore here also phi will be 0. So for undrained condition, in sigma 1 is equals to 2c only, or sigma 1 is unconfined compressive strength is equals to 2c, or c is equals to UCS by 2. Very important value, cohesion is equals to UCS by 2. Another test of laboratory test is vein shear test. In vein shear test, we should be knowing only 3 things. First, this test is suitable for soft saturated clay in marine which are marine clay होती है soft saturated clay, suitable for soft saturated clay or marine clay. हम जो इसमें फॉर्मूला यूज़ करते हैं वो 2 वे शेयर और 1 वे शेयर दोनों के लिए यूज़ होते हैं, राइट. So we find here the shear stress at failure, which is T divided by pi d square into h by 2 plus d by 6. D by 6 is for two-way shear, and as we get the one-way shear, we'll get shear stress at failure is equal to T divided by pi d square into h by 2 plus d by 12. This is for one-way shear. One-way shear and two-way shear. Both these formulas are important to determine the shear stress at failure by the Vane shear test. And also we should know that while doing Vane shear test, जब shear strength की value, shear strength of soil की value 2.7 kilonewton per meter square होती है, then we should know that this is the water content which is in the soil is liquid limit. And in the bore holes we do one way shear, ये भी ध्यान रखना है. After this we having direct shear test. Direct shear test is one of the oldest tests. This test is performed in by two ways. एक है stress controlled, एक है strain controlled. जनरली हम जो यूज़ करते हैं, मोस्टली यूज़ हम स्ट्रेन कंट्रोल करते हैं. स्ट्रेस कंट्रोल हम इसलिए लेस यूज़ करते हैं क्योंकि ये पुली और वेट की हेल्प के थ्रू होता है. इसमें वी डिटरमाइन द shear stress at failure which is Kn by A, where K is proving ring constant and N is dial gauge reading. K is proving ring constant and N is dial gauge reading. जनरली डायरेक्ट shear टेस्ट की जो चीज़ें पूछी जाती है वो है लिमिटेशंस. और वो सारी जो भी लिमिटेशंस है वो सारी ट्राइएक्सियल की मेरिट्स है. यहाँ पे क्या है, जो फेलियर प्लेन होता है इसमें वो प्री डिटरमाइंड होता है. अगर फेलियर प्लेन प्री डिटरमाइंड तो स्ट्रेस करने का ज़्यादा फ़ायदा नहीं होता, राइट. वन थिंग इज फेलियर प्लेन इज प्री डिटरमाइंड. कोई मैकेनिज्म नहीं है पोर प्रेशर के लिए, नो मैकेनिज्म फॉर पोर प्रेशर. ड्रेनेज कंडीशंस आर नॉट कंट्रोल्ड, ड्रेनेज इज नॉट कंट्रोल्ड and stress distribution is not uniform. Drainage is not control और साथ में stress distribution is not uniform. ठीक है. लास्ट जो टॉपिक है इस चैप्टर का वो है पोर प्रेशर पैरामीटर. पोर प्रेशर पैरामीटर, इसके भी दो फॉर्मूलाज हैं. उनसे कभी कभी जनरली कभी कभी क्वेश्चन आ जाते हैं. पोर प्रेशर पैरामीटर, हमारे दो पोर प्रेशर पैरामीटर होते हैं. फर्स्ट ऑफ ऑल वी शुड बी नोइंग दैट बी एंड ए रिप्रेजेंट्स द रिस्पॉन्स ऑफ चेंज इन पोर प्रेशर. बी और ए दो हमारे कांस्टेंट हैं, उनको हम पोर प्रेशर पैरामीटर बोलते हैं. और जनरली पोर प्रेशर पैरामीटर ना ही हमारा डायरेक्शन मेजर करता है ना ट्राइएक्सियल मेजर कर पाता है. तो हमारे को पोर प्रेशर कैलकुलेट करने का स्टैटिस्टिकल अप्रोच होता है या थ्योरेटिकल अप्रोच होता है. जैसे हमारा ट्राइएक्सियल टेस्ट का स्टेज 1 है कन्फाइनिंग प्रेशर स्टेज. उसमें जो हमारा पोर वाटर प्रेशर कांस्टेंट बी यूज़ होता है, जो कि है रेशियो ऑफ चेंज इन पोर प्रेशर टू चेंज इन कन्फाइनिंग स्ट्रेस, डेल्टा सिग्मा सी. और इसको हम ऐसे भी लिख सकते हैं डेल्टा यू बाय डेल्टा सिग्मा सी को हम लिखते हैं डेल्टा सिग्मा 3. ये है पोर प्रेशर कांस्टेंट बी. सॉरी, जनरली दो पोर प्रेशर पैरामीटर्स हैं, एक है बी और ए. इसमें ये चीज़ ध्यान में रखना, बी की वैल्यूज़ ड्राई सॉइल के लिए कितनी होगी, सैचुरेटेड के लिए कितनी होगी और पार्शियली सैचुरेटेड सॉइल के लिए कितनी होगी. अब देखो ड्राई सॉइल के लिए पोर प्रेशर से कुछ नहीं होगा, ज़ीरो, इसके लिए वन होगी, इसके लिए सॉरी इसके लिए ज़ीरो से वन के बीच में होगी। टाइप ऑफ सॉइल, राइट। ओके, दिस इज अ पोर प्रेशर पैरामीटर, द कांस्टेंट ए, और जो बी और जो ए है, ए इज डिफाइंड इन टर्म्स ऑफ ए बार विच इज ए नॉट इंटू बी। इसमें जो ए बार है, इट इज रेशियो ऑफ, इट इज डिफाइंड एज रेशियो ऑफ चेंज इन पोर प्रेशर टू अ चेंज इन डेविएट्रिक स्ट्रेस, और डेविएट्रिक स्ट्रेस इज ऑल्सो रिटन एज यू टू डेल्टा सिग्मा वन माइनस डेल्टा सिग्मा थ्री। तो यहाँ से हम इसको उन दोनों को कंबाइन करके एक इक्वेशन मिलती है हमारे को, जो ये दिख गया ना आप लोगों को। इन दोनों को कंबाइन करके इस इक्वेशन को और इस इक्वेशन को कंबाइन करके हमारे को एक जनरल इक्वेशन मिलती है पोर प्रेशर की, जो कि है बी इंटू डेल्टा सिग्मा थ्री प्लस ए इंटू डेल्टा सिग्मा वन माइनस डेल्टा सिग्मा थ्री। दिस इज ऑल्सो वन ऑफ द इम्पोर्टेंट इक्वेशन। ठीक है, और कुछ लास्ट के इम्पोर्टेंट पॉइंट्स जो कि शेयर कैरेक्टरिस्टिक ऑफ सैंड। अब इसमें हमारे को ये पता होना चाहिए सैंड कैसे फेल करती है। लास्ट के टॉपिक्स होते हैं, काफ़ी इंपॉर्टेंट होते हैं, कई बार इनसे क्वेश्चन आ जाते हैं। शेयर कैरेक्टरिस्टिक्स ऑफ, शेयर स्ट्रेंथ ऑफ सॉइल के लास्ट के टॉपिक्स हैं शेयर कैरेक्टरिस्टिक्स ऑफ सैंड। शेयर कैरेक्टरिस्टिक ऑफ सैंड बोलता है दो तरह की सैंड होती है, डेंस सैंड और लूज सैंड। डेंस सैंड में हमारा ब्रिटल फेलियर होता है जब हम ग्राफ बनाते हैं शेयर स्ट्रेस और शेयर स्ट्रेन के बीच। जब हम ग्राफ बनाते हैं शेयर स्ट्रेस और शेयर स्ट्रेन के बीच, तो ये यहाँ पे आएगा शेयर स्ट्रेस और इधर आएगा शेयर स्ट्रेन। देखो डेंस सैंड में हमारा ब्रिटल फेलियर हो जाता है और इसको हम बोलते हैं पोस्ट पीक ड्रॉप 2 to 5% में। मतलब यहाँ पे एक छोटा सा पोस्ट पीक ड्रॉप हो जाएगा, उसके बाद कॉन्स्टेंट 20 to 30% तक हमारा फेलियर आता है, 20 to 30% तक। ये पोस्ट पीक ड्रॉप जो होता है ये 2 to 5% में होता है। पोस्ट पीक, दिस इज पोस्ट पीक ड्रॉप, पोस्ट पीक ड्रॉप, और ये इसको हम बोलते हैं ब्रिटल फेलियर। यहाँ पे इसको हम बोलते हैं, इसको हम बोलते हैं ब्रिटल फेलियर। और इसके बाद होगा लूज